first step is to rewrite it into your left side and right sides. Rewrite this as your LS, and rewrite this as your RS. Now, on your Pythagorean theorem identities, you have sine squared x plus cos squared x equals 1. But I know that if I move my sine squared x over, I have cos squared x equals 1 minus sine squared x. So I can rip the 1 minus sine squared x off, throw it away, and replace it with cos squared x. And then I'm kind of stuck. I don't know what else I could do. Put it back to 1 minus sine squared x. Like, So I'm going to stop on that side because I don't know what to do. What could I do on the right side? Sine x is sine x. Cos x is cos x. Could I do anything with the cotan maybe? Yeah.
Turn it into cos over sine and then cancel sines.
Yeah. Getting a little ahead of yourself here, mister. I told you you'd like the puzzles. See, look at him. So we'd have sine x. We'd have cos x. And then we have cos x over sine x. Now what helps people sometimes is if I have a partial fraction here, if I write these over 1, it often helps people. So I'm going to write these over 1. And I put them in brackets to show its multiplication. Now, if everything is multiplied, can I cancel stuff off? Yeah, because they're all single. They're monomial, right? So then I can go here and I can say, hey, yeah, sine x squared. Sine x and sine x cancel. And then what am I left with? Cos x and cos x. What's cos x times cos x? Cos squared x, not cos x squared. Please make sure you write your squared where you need to. And then this is the moment where it's like, oh, because they match. And you're like, I'm not an idiot. This is amazing. Okay? Now, would my daughter in grade 3 look at cos squared x and cos squared x and say the images match? Yep. So now what can we do? LS equals RS. Yep, left side equals right side. If we do not write this, we will lose marks. Okay? You can write it below it if you want to. It doesn't really matter. I wrote it twice. You do not need to write it twice. So the images have to match. My grade 3 daughter has to be able to say those match. They look the same. And then LS equals RS. Okay? She doesn't know what cos squared x is, but she could say the pictures look the same. All right. Could you imagine if she could? Just pop out some grade 12 math. No big deal. She's impressed that she's so proud she can do her 10 times tables. Okay. She's pretty much a genius. All right. Looky here. What's the first step? What's your first step? Rewrite it with LS and RS, right? The only step I'm going to do, and then you're going to try it out. Try it out. We're going to try it out. Anyone have any suggestions of what I could swap anywhere? Tyson? Tan x can equal sine x over cos x. And we're going to multiply that by cos x over 1 over cosecant. Sure. I don't know why I put an equal sign there. Well. Anything else I could do?
1 minus cos squared x
is sine squared x off our formula sheet, the Pythagorean theorem identity. Yeah.
And then cosecant x can be 1 over sine x.
Okay, so we have sine x all over 1 over sine x. Do we ever stack fractions?
No.
No. So how should I have wrote that? Sine x. Instead of stacking it, what should I have done? Put it where? Rhymes with what she just said. Actually, it is exactly what she just said. Rhymes with aside.
Oh, hey, it's division symbol.
Yeah, and we put it where?
Like along the line. Like this.
Starts with a B. Rhymes with beside.
Yeah, that's what I mean.
Oh, there we go. Beside. Cool.
What left?
So we get sine x, then what do we do? Taisei, since you're on such a roll.
You multiply by sine over 1.
Yeah, the reciprocal. And we get?
Sine squared x.
Now some people will stop here and be like, ooh, cool, left side equals right side. My daughter, I promise you, although she's a genius with her 10 times 10 tables, would not be able to tell me that sine x times sine x and that look the same. She'd be like, no, Mom, you're an idiot. Those don't look the same. So I'm going to look at you and be like, you're an idiot. Those don't look the same. I'm not going to say it to you, because that's like a little bit of shaming. But I'm thinking it. I'm thinking it. Because you would get like your aunt, like how sad would that be? That like you were so, like you literally had the answer and now I have to take marks off. Saddest day. Make them match. Please. I'm saying this, and then what's going to happen is half you on the test are not going to do that. And you'll be like, but let, obviously. And I'll be like, but you're losing marks. And then that's how we are, and it's just sad. Okay. Now, do these match? Do these match? Are the images the same?
Yep.
Like I sound like I'm being ridiculous. I know. But then I mark, and then I'm like, gah, every time. Okay? LS equals RS. Don't forget that. All right. Fun times. We're going to try this one together. Go team. All right. Left side, right side. So I'm going to switch my tan x to sin x over cos x in my very first step, right? Because that's what you should do. We should switch the tan x to sin x over cos x and not write the tan x because we're cool and just completely bypass the very first step that we should write. Should we do that? No, that would be terrible, wouldn't it? Yeah. What's our very first step? Rewrite it. This everyone should get right. Like this should be the, every step should be right here on everyone. Anyone have any suggestions? Okay.
Turn 10 and then sine x over cos x.
Sure. Any other suggestions? Sure. Sydney?
The other side, the 1 minus cos 2x, can become 2 sine squared x.
Yeah, but how did you make that decision?
Use my calculation.
But why did you?
Rearrange.
But why? There's 3 of them. Why did you pick that one?
Because it's like probably the only one that works.
That's how I did it. It worked out for her, that's why. Okay, I would just do a little more educated guesses. You're just a genius and did it without any problems. But what I would do is if it were me and I were you, I would leave this one for a second because I have 3 options of it. You pick the correct one. Yeah. And I'll explain why you're such a genius. The bottom one, sine 2x, only has 1 option, right? That one we don't have options for. So I'm going to fill that one in first and see if maybe it helps me somehow in my battle. Okay? This is like a battle. That's what proofs are. They're a battle of getting the left side to equal the right side. So sine 2x on my formula sheet is a double angle identity, and there's only 1. So I'm going to go 2 sine x cos x. And I get aggressive with brackets because I like proving that these are all multiplied. You don't have to, but I'm all over it. Okay. We know that, and this is the thing, because Ty told us to switch the tan to sine over cos, I already know that ultimately in the end I want a cos on the bottom, right? Which means I need this 2 and this sine to get out of my life. I'm like, get out of my life, I want the images to match. The 2 and the sine got to get out, right? So, this is why genius Sydney chose what she chose. So we have 3 options of coses, okay? We could replace it with cos squared minus sine squared. Is that getting me anywhere closer to canceling off the 2 and the sine? No. Then I have 2 cos squared x minus 1. I need the sine to go away, not the cos to go away. So should I pick the cos one?
No.
No, maybe the sine one, right? So I'm going to put in 1 minus 2 sine squared x. Try it out. Worst case scenario, it doesn't work. You erase it and you try a different one. Like it's not like the end of the world exists because you wrote it and now you must use that for life. Okay? So it was 1 minus 2 sine squared x. The catch here that everyone gets this wrong is that they forget that this is a minus cos 2x and we're just replacing the cos 2x. You see that? So we have to remember to distribute that minus sign through. Do you know what I mean? And that isn't where the error lies sometimes. So I'm going to distribute it through, and I get 1 minus 1. Also something I want, because I need that 1 to get out of my life as well. And 1 minus 1 gets it to cancel off, right? So I have 1 minus 1, and then I need a plus 2 sine squared x. Now remember, if you're so close to having your images match and there's a sign issue, go back and be like, did I forget to distribute something through? Because if you forget to distribute that minus sign through, you're going to still have a negative 2 sine squared, and then you're going to get a negative sine x over cos x, and you're like, it's so close. Go back a step. You might have missed a distribution. Okay? These are going to cancel off because 1 minus 1 is 0. They go. And then we're left with 2 sine x cos x. So on the top I have 2, and yes, I'm doing an extra amount of steps. I don't care. Sine squared x. The 2 and the sine squared x are attached by multiplication, so I can put them in their own brackets, right? What is sine squared x what does it just mean?
Sine squared.
Yeah, so it means I have like sine x all squared, which means I have a sine x and a sine x. Is that not true? So could I just write it that way if I wanted to? Instead of writing sine squared x, could I just write sine x to prove a point? Yeah, it just means you have 2 of them. You have a sine x times a sine x. Because remember in your calculator, sine squared x you can't write because it opens up a bracket. So I told you have to write it as sine, it opens up a bracket, x. But then you have to do the whole thing squared, which just means sine x, right? Same thing. And then in the bottom we have 2. And this is when angels start singing, because you start seeing things match. These are all monomials, all multiplied. So things can cancel off. And then this is where, this is actually where the problem lies. And then they write LS equals RS. Once again, genius daughter, knows her 10 by 10 times tables in grade 3, basically genius, would say, Mom, those don't match. And I would say, yes, daughter, you are correct, and my student is wrong. And you'd say, but like literally Lepp, like I even cry, like, and I'm like, yeah.
Would you have to make 10x sine x over cos x on the left side, or just keep it as 10x but then convert?
You could do whatever you want as long as those images match. So I could have not touched this at all, left it a tan, and now say this equals tan, image, my daughter would say they're the same, then we can write LS equals RS. So the catch with marking proofs is I have to actually check and make sure you're not doing illegal math getting things, or if like you just did it just a little bit different. Because there's not just one way to get the images to match. Now, I would have went sine cos, because then that helps me sit here and go, oh, okay, I need a cos to sit here. What can I do to get to cancel? But nope, you wouldn't have to. So this equals sine x over cos x. And now my daughter would say the images match, and I would say LS equals RS. Oh, look, another one for you to try. And go. So we're doing, in your notes for tomorrow, we're skipping 5 and 6. We're going to do them tomorrow. You just need a little bit of info. 7, 8, 9, 10 in the notes. 11, 12. And we're going to go through them tomorrow. Hint for 12. Look at this. Wow, that looks like maybe something that could be factored. Factoring, so important. It's everywhere.
The first